All right, here we're reviewing absolute value equations and inequalities, and before we can really do that, let's review what the absolute value is. Remember, the absolute value is the distance from zero, and when we're counting the distance, we always count in terms of the positive, whether we're heading in the negative direction or not. For example, if we look at something like this, it says the absolute value -7. So think about where -7 is on the number line. It's right here. So let's count how many units away from zero. It's 1, 2, 3, 4, 5, 6, 7 units away. So the absolute value of -7 is actually +7. All right, because we're measuring the distance, -7 is the same distance away as +7. All right, so we just label them as the distance, which is 7 units away. Okay, if we look at something like the absolute value of 3, once again, if we were to count that distance from 0, if 3 is right here, we count over 1, 2, 3 units. So the distance from 0, well, the absolute value of 3 is 3. Okay? And really, one of the ways we quickly remember this is the absolute value always ends up being positive. And so here, the absolute value of 2 is a 2. The absolute value of -2 is also a 2. And those two are very telling when you look at the absolute value of 2 versus the absolute value of -2. They both give you the same answer because they're both the same distance away. Okay, so they're both the same number of units away from 0. That's why those two values give us the same answer when we talk about absolute value. Okay, and so applying that same thing here, if I look at this question, it says the absolute value of x equals 2. Well, if we look at these guys right here, it already answers that question. If the absolute value equals 2, well, that means the thing inside there could be a 2 or a -2. See, here's a 2 that gave me that value, and here's a -2 that gave me that same value. Okay, and so whenever we solve absolute value equations, we always have to do two values. We always have to do two distances. We always have two answers. Here, x would equal 2, or x would equal the -2. Okay, because if I want to be 2 units away from 0, I could do it in each direction. I could do it in the positive direction or in the negative direction. Likewise, if I have the absolute value of x equals 18, that means that x could equal an 18, or x could equal a -18. Those are both the same distance from 0, all right? They're both 18 units away, just in different directions. And then when you look at something like this, the absolute value of x equals a -3, well, the absolute value is always going to be positive. It can't be a negative, so this one would be no solution. That's impossible, okay? The absolute value has to equal a positive. If it equals a negative, we say, oh, well, that's impossible. It can't be done. It's no solution, okay? And so looking at some more complicated ones, again, we just split this up. We'd say, hey, the absolute value equals the positive version or the negative version, all right? What's inside the absolute value could be positive or negative and still give me that same distance, all right? So we just have to split it into two equations, all right? And that's all this is saying. What's inside the absolute value could equal this guy, or it could equal the opposite of this guy, all right? And so if I look at this first example, that means that the x plus 6 could equal an 11. That would be 11 units away. Or the x plus 6 could equal a -11, because that would also be 11 units away. All right? And then I solve each of these. So when this first one, to undo adding the 6, I'm going to subtract 6 from each side. The plus 6 and minus 6 cancel. So I get x equals a 5. And the next one, I subtract the 6 from each side. Again, the x plus 6 and the minus 6 cancel. So I get x equals a -17. And each of those would give me a valid answer. If I plug the 5 in, I get the absolute value of positive 11, which is 11 because it's 11 units away. If I plug the -7 in, I get a -11, but the absolute value of -11 is still a positive 11 because it's 11 units away. Okay? If I look at the next one, same kind of thing. I split it up. So I say 4c minus 2 equals the 6, or the 4c minus 2 equals the -6. All right? See, because again, when the absolute value equals 6, it's saying, hey, I'm 6 units away. Well, that could be a positive 6, or it could be a -6. Okay? And then I solve each, again, working backwards sort of operations. I undo the subtraction by adding 2 to each side. And now I undo that multiplication by dividing each side. Again, the multiplication and division cancel each other out. So I get c equals a 2. And now I have to do the same thing with the other equation. I undo the subtraction by adding a 2 to each side. The -2 and +2 cancel out. And now I undo the multiplication by dividing. Again, the times 4 and divided by 4 cancel out. And I get a -1. So there's my two answers. Okay? If I look at this one, this is that kind of special case I was talking about. It says the absolute value equals a -7. Don't even attempt this problem. Absolute value can't equal a negative. We say it's no solution, all right? It's just something that we have to be really careful of. We have to watch out for. And if you split this up and do the positive and negative, you'll get two answers, but neither of those answers will actually work if you plug them back in, okay? So remember, absolute value can't equal a negative, all right? If I look at the next one, once again, I split it up, so the 2x plus 4 equals the 2, or the 2x plus 4 equals the -2. Again, the absolute value is 2, which means the distance is 2. Well, there's two different values that are that far away, the +2 or the -2. It just really is saying, hey, we're 2 units away. Now we have to do two equations because it could be the positive version or the negative version, okay? And so now I solve each of these. I undo the addition first by subtracting. The +4 and -4 cancel out. I undo the multiplication with division. The times 2 and divided by 2 cancel out. And I get a -1. Over here, I undo the addition with subtraction. Again, the +4 and -4 cancel out. I undo that multiplication with division. Again, the times 2 and divided by 2 cancel out. So we get x equals a -3. Okay? And that's it. In terms of absolute value inequalities, we do the same thing as equations. We split it up and we do the positive and the negative version. But when we do the negative version, we have to flip that inequality sign. And then there's one other thing that we have to remember. Really, if we have two inequalities, that means it's a compound inequality. And there's only two types of compound inequalities we have, either an and inequality or an or inequality. So we have to label it appropriately. All right? And the way to remember this is you look at the absolute value. If the absolute value is less than, it's an and. If the absolute value is greater than, it's an or. All right? And so we memorize it this way. We say absolute value is less than is an and. The absolute value is greater is an or. All right? So make sure you include that and or that or. But really, it's the same as solving the equations. We just have to remember when to flip the inequality sign. So if I look at this one, the absolute value of x plus 5 is greater than 7. I still do the same thing. I still split it up, and I do two versions. So I've got the x plus 5 with the 7. I also do the x plus 5 with the -7. And I just have to make sure, hey, I keep this as a greater than symbol here, but I change it when I get to this one. Okay? When I do the negative version, I flip that inequality sign. And sorry, I went a little far over. I'm not going to have enough space for my next piece of this thing. So less than the -7. So again, that's really the main difference here. When I do the equations, I do the positive and negative version. Inequality is the same thing. I just have to flip that inequality sign for the negative version. And now I solve each. To undo adding 5, I subtract 5. So the plus 5 and minus 5 cancel, so I get greater than a 2. Over here, to undo adding the 5, I subtract the 5. Once again, the plus 5 and minus 5 cancel. So I get x is less than a -12. Okay? And then from here, I just need to determine, should I put an and or an or in between this? Well, right here, the absolute value is greater than, so greater is an or. So I put the word or in between, and I am done. Okay? Greater than the 2 or less than the -12. Okay? If I look at the next one, same kind of thing. I'm just going to split it up. So the positive version, I just leave this guy exactly the way it is. But when I do the negative version, I have to flip the inequality sign. So I do a greater than or equal to symbol when I do the negative version. And now I solve each. To undo adding 4, undo subtracting 4, I'm going to add 4 to each side. And the plus 4 and minus 4 cancel. Over here, same kind of thing. I'm going to add 4 to each side. So I get x is greater than or equal to a 2. And now once again, I just have to determine, do I put an and or an or in between here? Well, it's the absolute value is less than. So this is a less than symbol. So I'm going to do an and. And really what that's telling me, hey, I want to be bigger than the 2, but smaller than the 6. It's the values in between. Okay? If I look at this one, once again, split it up. So t plus 3 is greater than or equal to the 8. And then when I do the negative version, the t plus 3, I do less than or equal to the -8. I have to flip that inequality sign. And now I solve each of these here. I subtract the 3 from each side. So the plus 3 and minus 3 cancel. Sorry, that's a 5. Over here, I subtract the 3 from each side. Plus 3 and minus 3 cancel. And now I look at it and say, oh, it was the absolute value was greater than, so that's an or. So greater is an or. So I slap that or in between, and that's it. Bigger than the 5 or less than the negative 11. Okay? And then the last one here, once again, we split it up. When I do the negative version, I flip the inequality sign. And now I solve each of these. To solve this first one, to undo the subtraction, I'm going to add 3 to each side. And now to undo that multiplication, I do division. Sorry, I didn't show these canceling like I've been doing. Oops. Same thing here. And now I solve the other one. To undo the subtraction, I do addition. Again, that cancels. And now to undo that multiplication, I use division. But again, we're going through the same stuff that we've been doing. We're solving the inequalities the same way we solve equations, working backwards through order of operations. But the big thing with absolute value, you got to split it up. You have to do one positive and one negative version. That's true with equations. It's true with inequalities. Okay? With inequalities, we just have a little bit extra to do. We have to flip the inequality sign for the negative version. And at the end, we have to determine and or. This one, absolute value is less than, so it's an and. I just write the word and in between. Okay? So absolute value is the distance from 0. Always split it into 2 versions. And watch out for some of those little things like, hey, determining whether it's and or with the inequalities and making sure you flip that inequality sign. Okay?